Hey class, today we're going to be focusing on 11.3, find the perimeter and area of a figure. Although we've done this already, today we're going to be using a coordinate plane. So, quick recap from before. We got area formulas for parallelogram, that is base times height. We have a rectangle, which is also base times height. We have a trapezoid, which is going to be 1/2 the sum of the two bases, so base 1 plus base 2, times the height. Rhombus or kite, a rhombus is also a parallelogram, but they have their own special ones. That's going to be 1/2 times diagonal 1 times diagonal 2. And triangle, we have 1/2 the base times the height. And the final one, if we're recap, is the regular polygon, which is going to be 1/2 the apothem times the perimeter of the shape. So, getting right into our examples. Our first example should be pretty straightforward. We have find the perimeter and area of the triangle by these points. So we have F at 2, 8, right up here. G is at 4, 4. And H is at 2, 0. So here's my triangle. To start, if I want to find the perimeter, remember our perimeter is the distance around the shape. So since it's distance, we need to find all three side lengths. FH is easy. I can count that one out. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. We will have to do a couple other things for FG and GH. If we look at this, we make our right triangles. We have sides of 2 and 4, and same thing for GH. We have 2 and 4. So, I'm going to work through this to find, using Pythagorean theorem. So FG is equal to the square root of 2 squared plus 4 squared. GH is going to be the same thing. GH is going to be the square root of 2 squared plus 4 squared. Both of these will go to the square root of 20. So now for my perimeter, I just need to add all three sides up. 8, root 20, and root 20. So my perimeter is going to be 8 plus the square root of 20 plus the square root of 20. And I end up with approximately 16.944 units. Okay? For this one, go ahead and plug it in your calculator. We're not going to worry about the exact answer today. For area, we need to use our formula, 1/2 base times height. The thing to remember here is that the height is perpendicular to the base. So I can actually look at any of the three sides as my base, but I'm going to pick the easiest one. My base is right here. It's the length FH. So B in this case is going to be 8. Well, height is perpendicular, and it's going to go to the other vertex. So that's going to be right here. So my height is only 2 when I count that out on the coordinate grid. So my area here is going to be 1/2 times 8 times 2. So this area is going to be 8 square units. So triangles are pretty straightforward. We're looking at the coordinate grid, finding our base and height. Sometimes give you a little bit more of a trouble. So find the perimeter and area of the polygon with vertices defined by L, M, N, and P. So let's go ahead and plot these points. I've got L is at 3, 5. M is at 6, 8. N is at 9, 5. Right here. And then 6, 0 for P. So, when I look at the shape, I would probably lean towards kite. However, we don't want to assume that. To be a kite, you remember, it has to have 2 pairs of congruent sides, but not opposite sides are congruent. So we need consecutive sides that are, or adjacent sides that are congruent here. So to make this a little bit easier, we're going to find the length of all 4 sides. We're going to start with that. So again, I'm going to use Pythagorean theorem. If I draw these triangles around the outside of my shape here. So this one right here at LN is made up of 3 and 3. So is right here at MN, made up of 3 and 3. On N to P, I have 5 and 3. And then from O to L, I have 3 and 5 right here. So the length of LN is equal to the square root of 3 squared plus 3 squared, which is the square root of 18 when I put those together. MN is the square root of also 3 squared plus 3 squared, which is going to be square root of 18. So we know that these two are congruent. NO is equal to the square root of 3 squared plus 5 squared, which is the square root of 34. And then OL is the square root of 3 squared plus 5 squared, which is the square root of 34 as well. That means we know that these two are also congruent. For perimeter, I'm just going to add all 4 sides together. So I have the square root of 18 plus the square root of 18 plus the square root of 34 plus the square root of 34. For my approximate answer, I'm going to have 20.147 units, since I haven't defined specific dimensions here. Well, since I've shown that LM is congruent to MN, and PN and PL are congruent to each other, then that means I can, sorry about that. I just realized that I have O in here for some reason. That should be a P. That should be a P. My bad. Okay, so since I've shown which 2 pairs of sides are congruent, that means I definitely have a kite. And as we recall from earlier, that formula is going to be 1/2 diagonal 1 times diagonal 2. So in this scenario, my diagonals are defined by MP, and so D1 is going to be MP, which in this case has a length, I could just count it out as 8. Diagonal 2 is going to be defined as LN, and that has a length of 6. So for my area, 1/2 of 6 times 8. I multiply that out, I get 24 square units. Okay, for my next shape, I'll try this one. Find the perimeter area of this polygon with these vertices. We got A, B, C, and D. So, A is at -3, 0. B is at 3, 2. C is at 4, -1. And D is at -2, -3. Once again, I might make a quick assumption and it looks like it's a rectangle. I do not want to assume that though. I need to prove first that it's a rectangle before I assume that. So I'm going to start with finding all my lengths because I need to find them anyway for my perimeter. So I have AB, BC, CD, and AD. So, using Pythagorean theorem, I'll make right triangles on the outsides of all of these. Okay? AB is going to end up being the square root of 2 squared plus 6 squared, which is equal to the square root of 40. BC is the square root of 3 squared plus 1 squared, which is equal to the square root of 10. CD is the square root of 2 squared plus 6 squared, which is equal to square root of 40 again. And then AD is equal to the square root of 3 squared plus 1 squared, which is equal to the square root of 10. From this information, both pairs of opposite sides are congruent. I know it's a parallelogram. I can tell that for sure at the very least. Okay? So before I get to my full classification, let me go ahead and finish up the perimeter. So that's square root of 40 plus square root of 10 plus square root of 40 plus square root of 10. Go ahead and plug those in your calculator and you're going to end up getting 18.974 units, approximately. Okay? Well, to help with my classification, if I think it's a rectangle, I need to know something else. Either I need to know that diagonals are congruent or that the side lengths are forming 90-degree angles. Well, remember, on a coordinate grid, to form 90-degree angles, slopes have to be opposite reciprocals. So if I look at the slope of BC, this one is a -3/1, if I count it out. Opposite that, AD here is also -3/1. If I look at the slope of AB and DC, if find out that this counting it out is a positive 2 over 6, which reduces to 1/3. And then the same thing for CD. Positive 2 over 6 reduces to 1/3. So I have opposite reciprocals. Therefore, my shape, we have a rectangle for sure, which means it's going to be base times height. So now that I have that, I'm just going to use the length, since my rectangle has a base of the square root of 40. Okay, it's going to be the square root of 40 for my base times the height of a square root of 10. So area is going to be the square root of 400 when I put those together, which is comes out to 20 square units. For my last example, not every problem is going to be as simple as using the right formula. Here I have a quadrilateral that's in my coordinate grid. It's not officially anything. It looks like it might be a kite. However, this side here is 3, BC is 4. So when I look at this problem, it's not going to work in terms of a kite. So I can't use my diagonals. Instead, for a strategy, I'm going to make a shape around it. We could try to break it up into smaller shapes. It's going to get complicated if that's what we do. Instead, I'm going to draw a rectangle that goes all the way around my quadrilateral. So the area of the quadrilateral ABCD is going to equal to the rectangle minus these two little triangles on the outsides. So all I have to do is figure out first, I'm going to find the area of the rectangle. Okay, so that is going to be made up of a base times height. So my base is going to equal to 4 plus 2, which is equal to 6. My height is going to be 3 plus 2, which gives me 5. So for my area of my rectangle, it's going to be 6 times 5, which is going to give me 30 square units. Now I need to find both of my other triangles. Well, my first triangle here, where at AD has a base of 2, and I can call it a height of 6 here. My second triangle has a base of 2 and a height of 5. So area of triangle 1 is going to be 1/2 of 2 times 6. Area of triangle 2 is going to be 1/2 of 2 times 5. Multiply these out so that the area of triangle 1 is going to be 6 square units. Area of triangle 2 is going to be 5 square units. So that means my total area is going to be the rectangle area minus first triangle minus the second triangle, which comes out to 19 square units. That concludes our lesson for today. If you have questions, please come find me whenever you can during AIM or any of the other off periods. Otherwise, I will see you in class next time I see you. Thank you.